Hi, my name is Noah. Thanks for checking out this video. You're probably watching this because you saw my Got Data flyer, so I just wanted to take a second to kind of show you what all that was about, what I can do, and kind of how it works. So, what you're looking at here is an Excel spreadsheet showing data about Titanic passengers. We've got their name, what class they were in, whether or not they were male or female, what they paid for their ticket, where they boarded, and ultimately whether or not they survived. We've actually got quite a lot, just under 900 rows worth of data, and you can see it all here. So let's say, for example, there was something you wanted to change in this data. Maybe you didn't want the S here to represent Southampton. You'd like the full name of the town written out. Maybe these names are not formatted correctly. They're kind of odd with the title in the middle. These ticket numbers don't make a lot of sense, and of course the fares aren't updated to represent inflation. So if you wanted to make these changes, to do them by hand would take you forever. It's not realistic with 900 columns. So I'm going to show you how we do that. We actually don't use Excel. We use a programming language called Python, which is what you're looking at here. So the first thing we'll do is go ahead and load the data, and this is called a data frame. It's essentially just an Excel spreadsheet in Python, and you can see we've got all of the same information that we did before for all 891 passengers. So maybe what we want to do is sort this data frame, sort this Excel spreadsheet so that we can answer specific questions. For example, maybe we only want to look at passengers who had a survived value equal to 1, indicating that they did in fact survive. Well, we can do that really easily. We can just sort the data frame. We end up with 342 rows, 342 passengers, and it looks like they all survived here. So 342 out of those original 891 passengers survived. And we can figure out what the survival rate is. It's about 40%. We could ask, who was the youngest passenger on board? Well, his name looks like Alexander Thomas. He was less than a year old. We could also ask who the oldest passenger was. It was this guy, Henry Wilson Barkworth. He was 80 years old. We can get a bunch of other information about the age of the passenger. We can get the average age was about 30. Standard deviation was about 15 years. The 75th percentile was only 38. A lot of these people were really young, and certainly the max age of 80 was quite old for one of these passengers. We could ask a really weird question, like what was the average age of all the female passengers in second class who survived the sinking and boarded the ship from Southampton? So we're going to define some conditions. The first is that the passenger is female. They were in second class. They did survive. They boarded from Southampton. And we're going to do this same sub-sampling thing. So now we have a new data frame. There's only 61 rows. Only 61 passengers of those 891 met this condition. You can see they're all female. They were all in second class. They all survived. And they all boarded in Southampton. The S here stands for Southampton. We can see the average age was about 30 years old, 29 years old. We could even plot a histogram showing the distribution of ages for these passengers. And you can see the median and the average look to be centered pretty nicely around 30 or 29, which is kind of what we predicted right here. The other thing we can do with this Python coding sort of scheme is clean up the data to make it usable. I had said before that S here stands for Southampton. You can see Southampton. You can also see there's a Queensland in here somewhere. There it is, for Q for Queensland. It's hard to read. It's hard to know exactly what that is. Maybe we want to put the actual city name in. Well, we can just write some function to do that for us, run this, and there you go. There's all 891 rows with Southampton, Queenstown, Cherbourg. So that makes the whole data frame a lot easier. There's also a lot of missing values in this cabin column. You can see this NaN thing. It means not a number. It means we don't have any information there. We could guess, we could leave it. In this case, there's a lot of missing values in the cabin column. So I think we'll just go ahead and get rid of it. it cleans things up. We don't really need it. You can see all 900 rows again. We've gotten rid of the cabin column. The ticket number, if you look, is kind of weird. This is ticket 21,171. There's this weird A5 prefix. I don't know what this prefix means. I don't know what that means. We just want the number. Well, again, we can write some custom function using something called regular expressions, and that can help us clean up these ticket columns. So now we're just left with a nice number that we can use. Certainly is a lot more readable. The other thing, the fare here is still in 1912 British pounds, and maybe we wanted to know what that was in 2023 US dollars. So we've got an exchange rate here, about $180 per pound in 1912. So we can go ahead and update this, and now this shows the updated fare in 2023 dollars. $1,300, $13,000. This guy paid a little under $10,000. Looks like the average ticket price was about $5,800, so that's interesting. The last thing here that makes this really hard to work with are these names. We have a last name, we have a title, we have a first name and a middle name, and so that one's not too bad. But then we've got like this, there's like a nickname or something here, and we've got, this is MISS, and some are, Mrs. rather than Miss. It's just not very consistent. It's not very nice to work with. So we can define another custom function here, and that's really what a lot of this stuff is figuring out what problem do you need to solve and what sort of function do we need to write which is going to give us back the thing that we want to know. So this particular function is going to give us just the first and last name here, and you can see it makes everything a lot easier to read. So maybe you sent me an email and you said, Noah, I've got this Excel spreadsheet with all of this Titanic data, and I need you to update the fare prices to represent dollar denominations in 2023. I need you to get rid of the things in front of the ticket price. The names are unreadable, fix that. I want to be able to read the city. So, okay, I do this. How do I get this back to you? This isn't useful. You need this back, and you obviously don't want to learn to code. So what I can do, the other thing I was going to mention, I can go ahead and sort these names alphabetically. What I can do is save this data frame as an Excel file again. So if we go back to the folder where I had this original Titanic data, there's now a modified version, and if I open this, it gives me a Excel file, just like normal, but all of these changes are still there. The names are sorted, they look nice, the ticket prices are updated, the fare prices are updated, the embarkment location is updated, and this is consistent for all 891 passengers. Would have taken you forever to do this by hand, and this is just a bog standard Excel spreadsheet. I can email this to you. You can do whatever you need with it. It's exactly the same as this one in terms of functionality. The only thing is I've cleaned up a lot of the things here that were really annoying and made this hard to work with. You can take this now. You have an email mailing list, a list of customers, whatever you need. It looks nice and it does what you need. The last thing I kind of wanted to show you is how we use data to make predictions. This is some basic machine learning stuff, which is kind of beyond what I want to talk about right now. But essentially, we're going to take 700 of these passengers, and we're going to look at their age, what they paid for a ticket, whether or not they were a man or a woman, and we're going to try and use that information to predict whether or not they survived the journey. And what we're going to do is we're going to take 15 passengers chosen at random, and we're going to see how well our model works. So if we look, this is the data that we're going to train the computer with, because obviously this is going to be a machine learning process. We have the age, the fare. These are normalized between 0 and 1, but we also know whether or not they were a man or a woman, and we want to use these 3 columns of information to predict whether or not that passenger was likely to survive. And then we have those 15 passengers that I set aside. We know their age, we know what they paid for a ticket, we know if they were a man or woman. What we don't know is whether or not they survived, so we're going to predict that. And we're going to train what's called a random forest classifier, and you saw how long that took. we got a 98% training accuracy, which is pretty good. The reality is 900 rows of data in an Excel file is really small. You can do these things all day long. They do not take a lot of time for 900 entries. But 98%, that's looking really good. You'd be impressed with that. It doesn't really relate to how well the model works to predict these, though. So what we need to do is predict, make some predictions about this data, and we're going to do that right here. We get a test accuracy of about 70%, which is not bad. I mean, considering we only have 15 passengers here, that's like, 4 missed out of 15 or something like that. But we can look, passenger 12, he really did perish. We predicted that. Passenger 880 survived. We predicted that too. Passenger 434 died. We predicted he survived. You can see more. Passenger 41, he really did die. We predicted he survived. Maybe we'll look at that. Passenger 41, Johan Aline. She was a female, age 40 years old, paid this much for a ticket. So you can get some ideas. She did board from Southampton, so you get some ideas about this passenger. We could make our own passenger, which is kind of what machine learning is all about. We want to make predictions based off of new information. So we'll make up somebody named John. He's 26, paid $1,000 for his ticket, and he's a man. And we want to see, was he likely to survive? So we run our randomforest.predict function, and this passenger is likely to have perished, which makes sense. He was young, probably in 3rd class. He was a man, and we know that's what happened to most of the passengers on board the Titanic. So these machine learning models are relatively easy to do, even with a lot of data. All of this cleaning up is easy to do still with a lot of data. It's very easy to tell you specific things like how many passengers survived. Python is a really powerful tool to be able to do that. So I hope that gives you kind of an idea about the services that I offer and the sort of things that I can do. If you have any questions, send me an email. Thanks.